Question 3, they give you a function fx defined for x more than 3 over 2, and they give you f prime 10x minus 9 over 2x minus 3. Part 1, express your f prime in the form of a plus b over 2x minus 3. First of all, do notice that your f prime is an improper fraction. Why? Because the powers of x are both power 1, which means improper fraction. And what you can do is long division. My quotient will be 5 and my remainder would be 6. So how I'm going to represent this is 5 plus 6 over 2x minus 3, because 6 is my remainder. So a good habit is also to tell me what is my A. A is 5, my B equals to 6. And that will be the answer. Second question is a hence. Hence, explain whether fx is increasing or decreasing. So you need to recall increasing, decreasing function. Increasing means f prime is more than 0. Decreasing is f prime, or my first derivative, is less than 0. A good thing to take note is my x is always more than 3 over 2. So looking at my f prime, what do you think the nature of f prime would be? It will be more than 0. Okay, but let's write it out first. If x is more than 3 over 2, we explain that 2x minus 3 will be also more than 0. Hence, my f prime will always be more than 0, which means positive. I can conclude that it's an increasing function. Alright, so once I say that, then I have answered the question fully. Part 3 is to consider my f prime prime and explain whether f prime is increasing or decreasing. This is quite similar to part 2, but we have to consider f prime prime, and that's what we will figure out first. So from part 1, I already got my f prime. To get my f prime prime, I need to differentiate one more time. So what I will do is, let's take a look at the function and see whether we can simplify it. My 6 over 2x minus 3. I can simplify it to 2x minus 3 power negative 1. So that I get ready for differentiation, bring down power minus 1. If I differentiate my 5, it will become a 0, which might as well don't need to write it. But differentiating the second one is I bring down power, keep the terms, power minus 1, multiply by terms inside. Then differentiate terms inside. Differentiate terms inside, which is a times 2. I should simplify this. This will be my f prime prime, negative 12 over 2x plus 3, whole thing square. We go back to answering the question. They want us to find what is f prime function. To answer that, I need to consider my f prime prime, whether is it positive or negative. So if my x is more than 3 over 2, actually for my denominator, this denominator will always be more than 0 because it's a square for any x values. And since this is always more than 0, then my f prime prime will always be negative. So less than 0. And since f prime prime is less than 0, I can conclude that f prime is a decreasing function. And this is how I prove f prime is a decreasing function. Part 4 is to obtain expression for f prime given that f2 equals to 8. So this will sum up everything from the start to the end, because the start gave me f prime. And to go back to fx, I need to do something. What I need to do is to integrate. But how many times do I need to integrate? Just 1 from f prime. I'm going to use my result for part 1 to integrate to get my fx. Integrate 5 will give me 5x. Then I move on to 6 over 2x minus 3. Notice that this is a power minus 1 case. So power minus 1, if I integrate it, it will become a ln. Ln the denominator divide by coefficient of x. My coefficient of x is 2. Divide by 2, don't forget to plus C. I can simplify by dividing common factor. What I left is 3 ln 2x minus 3. By using the information they give us, f2 equals to 8, I should find my value of C. My C equals to negative 2, so I'm going to solve it back into the equation to find my total expression. So eventually my answer would be 5x plus 3 ln 2x minus 3 minus 2. So these are my whole workings for part 4.